Hi, I'm Brandon. I made this video for first-time and beginner users of a data mining program called Weka. So you've already got your data file for Weka, an R for CSV file probably, and you want to get a little familiar with Weka using some of those popular algorithms you've heard about like logistic regression, decision tree, neural network, and support vector machine, and you just simply want to get your feet wet with Weka. You can get to the initial screen in Weka by opening your data file, and now you'd find it helpful to see examples of data pre-processing, building models, and interpreting results in Weka. Well, at the risk of redundancy, this demo is only for first-time or beginner users of Weka. It's barely even going to scratch the surface. You won't be able to apply even the intermediate data mining techniques that Weka is based on after watching this. But when I learn brand new things, I like to start with analogies, examples, and even the simplest of demonstrations. At this point, I may tell you Weka is actually not complicated given what it can do, how it's very straightforward and easy to use. But if you're like me, that won't resonate until you see some do-it-yourself Weka examples and exercises. Let's get started now data mining with Weka. So you've probably already seen this initial screen when you open your dataset in Weka Explorer. While a helpful screen showing you some things about the dataset, it most certainly is not why people use Weka. The Classify tab is where it most commonly does its thing, and will contain the four algorithms I'll demo, which again are logistic regression, decision tree, neural network, and support vector machine. I'll run my data in Weka using logistic regression in a moment, but would like to say one last thing in opening. So many people learning Weka have systems in mind for improved decision making. The knowledge for such systems can be based on thinking people as well as thinking machines. Thinking machines is what Weka does best. Weka is a collection of quote-unquote machine learning algorithms. Machine learning is a form of artificial intelligence. Artificial intelligence is a form of computer science with software capable of self-modification, programs capable of changing themselves, programs capable of improving themselves. Let's say I want to train a computer to train itself to play chess. Maybe I'll have it do a logistic regression algorithm in Weka. Let's say I want my dataset to dispense live personalized advice resembling Amazon's customers who buy X also buy Y. Maybe I'll have it do a nearest neighbor algorithm in Weka. This demo won't emphasize Weka's machine learning, artificial intelligence approach to knowledge discovery. It may feel more so like deriving knowledge from classical statistical techniques. Weka can do human learning or thinking people data analysis as well. That's mostly how I got familiar with Weka, and that's mostly what I'm about to show. Last thought I promise before we start is that if you haven't heard of a hybrid knowledge system for decision making, or understood where knowledge based on machines that learn to think begins, I hope after watching this you'll be able to visualize the Weka toolkit and how machine-based advice in these knowledge systems actually started interpreting data. Very briefly, let me show you the data that I used when I got my feet wet with Weka, which I used for this demo. It's basic info about my heart over 20 days. I collected 4 measurements per day using a chest belt. So it's 80 measurements. Each measurement has 7 data points associated with it. I was not trying to use this data set in Weka to discover useful knowledge. I chose this data set because I collected it. I had already studied it from many angles, and since I was familiar with each measurement and metric, it helped my Weka learning curve. For example, a seemingly simple variable confused the J48 decision tree algorithm, but I knew the data and immediately knew why. So let's look at the graph. Red indicates a successful grade, blue indicates an unsuccessful grade. The first 2 data points were numbers that the chest belt device gave me as is. As we can see for the first metric, heart rate variability, there was a direct relationship. Higher is better. As we can see for the second metric, heartbeats per minute, there was an indirect relationship. lower is better. The other 5 data points were not given to me as is. That's where you, the data miner, put on your thinking cap to decide how to tweak your data and provide Weka capability of discovering useful information. This is part of pre-processing, and not to editorialize, but if you have initiative and aptitude for data pre-processing techniques, you'll be effective at data mining with Weka. The third metric, day ID, was the day 1 through 20 that I took the heart measurement on. The fourth metric, sequence ID, was whether it was that day's first, second, third, or fourth measurement. The fifth metric, pattern sleep, was if the measurement was taken when my sleep pattern was irregular or regular. In the first 40 measurements, sleep time was very erratic. In the last 40 measurements, sleep times were very similar. The sixth metric, hours awake, was hours awake at time of measurement. I measured when I woke up, 2 to 5 hours after that, 2 to 5 hours after that, and 2 or more hours after that before I went to sleep. And the seventh metric, health grade, was the aforementioned success or failure grade. Measurements with heart rate variability of 70.0 or above were considered successful, and below 70.0 were considered unsuccessful. To see what the data set may look like in a spreadsheet program, let's click Edit. Scrolling down, we see all 80 measurements, or as they're called in Weka, instances. On top for each instance, we see all 7 of what are called in Weka attributes. But this is the kind of terminology you don't care about until you see Weka in action. Let's start with logistic regression in Weka. Classify, choose, functions, logistic. In some cases it may not let you at first. If so, don't sweat it. Later on, that's one of the things we're going to learn about Weka. You may be wondering what logistic regression is, but not able to understand what it says when you right-click for its properties. If so, it's a highly regarded classical statistical technique for making predictions. If you get good in Weka tomorrow, you may want to train a logistic regression formula so it can learn with increasing accuracy to predict something. Using Weka for the first time, I remember just wanting to see a basic example. So with 80 past events to go off of, and each event had up to 7 attributes, I pictured a CEO asking me how accurately, if I had only the first and 6th attribute, logistic regression could predict the 7th. That is, when the 81st event happens, how accurately can it predict 7 just based on how 1 and 6 related to one another the first 80 times? So next I was going to click the other attributes, remove them from the data set, and run the logistic regression just with 1, 6, and 7. Since I was learning Weka for the first time, however, I figured why not also run logistic regression with all the data points we've got. Would a logistic regression formula more accurately predict with 2 or 6 data points? I ran logistic regression twice, and along the way learned some introductory Weka concepts. In Classify, I looked at the pull-down menu and saw that's where you can put what you're predicting. The CEO asked me to predict the health grade attribute. I also thought, what if the CEO asked me to predict another attribute, like heart rate variability? I clicked Start and saw it said can't do numeric classes. Here it's grayed out, but when I did it, there was an error and it said cannot handle this type of class. So in Weka, when you get your feet wet, this is one of the first things you'll notice. Any algorithm cannot predict any data point. This logistic regression algorithm won't predict numeric class data, but it will predict nominal class data. Next, I asked myself which to use in test options. Use training set would have run logistic regression on the data file as is. Since I'm coming up with a predictive model though, I ended up going with tenfold cross-validation instead, as it challenges the logistic regression a bit more and makes its ability to accurately predict ultimately more valid. What I mean by that is if that CEO knows some statistics and wants to take my predictive analysis seriously, I may be asked when testing my formula if I ran it through any cross-validation. Later we'll take a closer look at what that means. So relating all these 6 data attributes, a heart rate score, another heart rate score, the day number, things like that. Let's see what the first logistic regression formula starts out as. To run logistic regression and classify, start, and on top we see the formula. It's taken the 6 attributes and assigned a weight to each of them. So with all 6, logistic regression initially predicted with 92.5% accuracy. As I interpreted the data, I looked on bottom at the confusion matrix and see it gets tripped up more on the successfuls, where it's 32 out of 36 correct, than the unsuccessfuls, where it's 42 out of 44 correct. Now let's see if we go back and only use those 2 data points, if that helps or hurts this logistic regression algorithm in its prediction accuracy. We click the data points we don't need and click remove. So this was my original formula. We have here 2 independent variables, and based on how they relate to each other, we're going to see how close we can predict the dependent or outcome variable. Again, in the pull down menu, if we try to make the dependent or outcome variable heart rate variability, this logistic regression algorithm tells us it's not going to do numeric classes. Now, let's run it again, and this time we get 98.75% prediction accuracy. On bottom, we see all 44 unsuccessful measurements were predicted correctly, and 35 of 36 successfuls were predicted correctly. For this logistic regression algorithm, removing data points during pre-processing improved the algorithm, which is not always the case. And this was another one of those first time seeing it in Weka lessons. Some algorithms like this, it's inefficient to just throw all the data that you can at it. Whereas other algorithms, like J48 decision tree, it's the more efficient thing to do. Let's click classify, choose trees J48, which is a decision tree. And again, I asked myself hypothetically, what do I want this decision tree formula to try to predict and find out for me? Well, since logistic regression did not work with numeric classes, I figured I'd try to predict a numeric class this time. So again, I went to the pull down menu and said, let's use decision tree to predict heart rate variability. That is, if I give this decision tree algorithm all 6 data points, how accurately can it predict the 7th one? Or can it at all? As that logistic regression algorithm, this J48 decision tree algorithm does not work with numeric classes. J48 does work with nominal classes. And since I had 3, I ran each in decision tree just to get a little more familiar with Weka. First, I did health grade, and as you can see, it predicted 100% accurately. To see how, I clicked Visualize Tree. It looked at all 6 data points and picked heart rate variability as the most relative for a prediction. Based on one question, in fact. Was the HRV above, below, or equal to 69.5? It predicted 100% if health grade was successful or unsuccessful. A small but neat thing too is that I graded success if it was above or below 70, and the decision tree here says you actually didn't have any 69.6 to 70, so 69.5 is your actual line in the sand to classify success. And so that gave me a clearer way of thinking about a metric. Next, I put pattern sleep in the pull down menu, and again decision tree got 100%. I clicked Visualize Tree, and it showed it related day ID most to the outcome variable. Was the day ID more than 10? It could predict based off this one question. But the third nominal class variable was not as simple to predict. Sequence ID was predicted only 86.25% of the time. Visualizing the decision tree shows what the model settled on. The formula started with the hours awake variable. Further down it added the day ID variable, but at certain points I saw uncertainty. The tree is reflecting the confusion matrix. Let's look at the sequence ID variable to see why. It looks nice and segmented, but it has overlap. I took 4 heart measurements each day. First, as soon as I woke up. Second, about 2 to 5 hours after that. Third, about 2 to 5 hours after that. And fourth, 2 or more hours after that, before I went to sleep. So the second sequence can have a 5-hour. The third can have a 5-hour. The third can have a 7-hour. The fourth can have a 7-hour. So now you see why it's so easy to predict the first one, and it's so difficult to predict the middle ones. And along those lines, Decision Tree showed me another introductory Weka lesson. After 18 days, it was only 83% accurate. I saw this Decision Tree algorithm improve to the 86% with 8 more instances. So we can assume with more instances or more attributes, this tree will have more potential branches and get more and more accurate. Next up was neural network. Click Classify, choose Functions, Multi-layer perceptron, which is a neural network. You see multi-layer perceptron, think neural network. Again, to get my feet wet with neural network, I stepped back and considered a hypothetical. I asked what could I want neural network to predict or find out for me. I chose 2 things. First, predict the complex sequence ID variable, which gave the decision tree trouble. Second, I wanted to predict a numeric class, HRV again, because the first 2 algorithms only worked with nominal class. And again, I asked if I should remove some data points, like in logistic regression, or leave them all, like in decision tree. It seemed that the more data points multi-layer perceptron had, the better, so I left all 7 in. I looked at test options and chose percentage split this time. Testing at 66% split means it builds its initial model or formula using 53 of the 80 instances, which again were heart measurements that I took. And after the initial model is built, it runs it on the last third, or 27 instances, to test its accuracy. So let's see how accurate the algorithm was in predicting sequence ID on that fresh set of 27 instances that it held out for testing. Well, it was 89%, as you saw, and the first sequence it got them all right, but as again the middle ones, there's uncertainty, and as you can see, the last one, it got them all right. I looked up at the model that it built and didn't quite understand it, but it was helpful nonetheless to see now a third unique algorithm in Weka that can be used for data analysis. I was just trying to get initial experience with Weka, and thus was happy to see multi-layer perceptron, a neural network algorithm that can handle a numeric class such as HRV. I clicked Start, looked at the results, and noticed numeric class did not have an identical summary as nominal class. Remember how it got 24 of 27 correctly classed instances, or 89%? Well, here with numeric, it seemed less correct versus incorrect. Instead of saying it got 0 out of 27 correct, the emphasis seemed more on how close it got. Error statistics were in the summary, but here I went to more options so I could output prediction and see accuracy in another way. I reran it, and output prediction showed what this neural network model predicted for those 27 side by side with the actual values. My first thought was this is the kind of thing I can paste into a spreadsheet for anyone to understand, say needing to ask, are these predictions close enough? Because here's where we're at with the model. And I thought of them without knowing what root mean square error is, saying, yes, I see a close enough accuracy rate here between these two. It's useful now. or maybe them saying no, it's not useful now. Finally, with neural network, to visualize the formula, I turned the GUI on by right-clicking where it said multi-layer perceptron. So properties, GUI, make true, okay. To run it again, I click start. And I thought this visual is pretty self-explanatory, and you could see why they call it neural network. And on the bottom, those are events. With more events, this algorithm's error rate decreases over time. So I can plug in 50,000 events, for example, and it'll get smarter. Last, I looked at one more type of algorithm in Weka called support vector machine. Classify, choose, functions. See, there's SMO and SMO reg. Both are based on support vector machine if you look at the properties of them. And you'll see that even though both are based on support vector machine, they're different algorithms. Let's choose SMO reg to predict a nominal variable. Here we see the reverse of before. This algorithm won't accept nominal class, but it will accept numeric class. Another introductory lesson. This doesn't mean what's nominal class can't ever work with SMO reg. I may be able to edit something nominal class just by opening the data file and representing the data differently and saving the variable, this time as a numeric class, for example. Or I may want to run one of the many filters in Weka. As a data miner, you spend a bunch of time changing data in ways that can make an algorithm more efficient. Those are some examples, again, of what's called data preprocessing, and data preprocessing is a big part of using Weka. Now let's use the training set as is, without any cross-validation. To see what it looks like, let's also check output predictions. Take note of the original order being intact and left as is. Now let's run tenfold cross-validation. Here are 10 consecutive 1 through 8, 1 through 8, 1 through 8 for my 80 instances. Let's compare their prediction accuracy. With tenfold cross-validation, the mean absolute error is 2.75 and the root mean square is 3.5. How does that compare to the test without cross-validation? In the result list, I clicked it, less error, but now I saw why it's less valid as a predictive model. This demo was made with first-time and beginner Weka users in mind. I hope it provides them a few things which make comprehending Weka easier and faster. Have fun using Weka. Thank you.